Welcome back to my channel, dear students. Now I am going to discuss about the galvanic cell or a voltaic cell. Okay, the best example of galvanic cell is a Daniell cell. So I am going to discuss about construction and working of a Daniell cell. So in the electrochemical cell, there are two types, galvanic cell and electrolytic cell. So the galvanic cell is also called voltaic cell. The cell in which chemical energy of spontaneous redox reaction is converted into the electrical energy or called galvanic cell or a voltaic cell. Here in a galvanic cell, the spontaneous redox reaction occurs and the chemical energy will be converted into a electrical energy. Okay, that is considered as, or that is called as a galvanic cell or a voltaic cell. So for the galvanic cell, the examples are mentioned here: Daniell cell, mercury cell, nickel cadmium cell, and the lithium ion cell. Okay, here I am going to discuss about a construction and working of a Daniell cell. So here the Daniell cell consisting of two metallic rods. The one is zinc and another one is copper. So the zinc rod is dipped into a 1 molar concentration of a zinc sulfate solution, and a copper rod is dipped into the 1 molar concentration of a copper sulfate solution. Here these two solutions are interconnected with the help of a salt bridge. We know that a salt bridge is a U-shaped glass tube and it is containing a agar. Okay, consisting of a agar. Okay, this is nothing but agar is a salt solution. It may be a KCl or potassium nitrate or ammonium nitrate. So here a salt bridge which it is the interconnecting between the two solution. So here the two electrodes are externally connected with a metallic wire. So this is what a construction of a Daniell cell. Here at the anode side we know that the oxidation occurs and at the cathode side the reduction occurs. Here the zinc electrode which releases the electrons and they can flow from zinc to copper. So the electrons moves from here anode to cathode, and in the cathode the electrons will be deposited on a copper rod or a copper electrode. So here at the anode the oxidation occurs and at the cathode the reduction occurs. Now the electrons flows from zinc to copper and the current flows from copper to zinc. So this is the working of a Daniell cell. Here the cell reaction involves the total cell reaction in a Daniell cell. We have at anode, so the oxidation occurs, that is Zn, by the loss of electrons, Zn2 plus 2 electrons, and at the cathode the reduction occurs, that is copper 2 plus 2 electrons, that is gain of electrons, it becomes a copper. Now the total, this is called a half cell reaction and this is the half cell reaction. Now the total reaction becomes, the two electrons get cancelled, that is Zn plus copper 2 plus is equal to Zn2 plus and copper. Here the oxidation occurs and here the reduction occurs. The combination of these two half cell which combines the one electrochemical cell, that is the Daniell cell. Okay, the functions of Daniell cell. Okay, the functions of Daniell cell. So here there are three main functions. We know that in a Daniell cell which produces a 1.1 volt electrical energy. So here, if the applied potential energy is less than 1.1 volt, which acts as a same as that of a Daniell cell. So if the applied potential is equal to the 1.1 volt, so there is no flow of electrons or there is no flow of electricity, means there is no chemical reaction occurs at when the applied potential is equal to 1.1 volt. Okay, then third one is if the applied potential is more than 1.1 volt. Here the cell reaction get reverse, means it acts as a electrolytic cell. Here in a Daniell cell the electrons moves from anode to cathode and the current flows from cathode to anode. Okay, in case of if the applied potential is greater than 1.1 volt, here the electrons moves from copper to zinc and the current flows from zinc to cathode, means it acts as a electrolytic cell. Hope you understand the concept, that is the construction and working of a Daniell cell. Thank you.